Hi, welcome to this lesson on calculus, finding tangents to functions. Let's have a look at question 6. So we're given the function f of x is this quadratic function, 4x squared minus 2x plus 1. And we're given that y equals 14x minus 15 is the tangent line to the point PAB. Then we want to find the values of a and b and the equation of the normal line to PAB. Okay, so two things we need to do here. So let's get an interpretation of what's actually happening in this question. So that function we can actually draw pretty well with good accuracy because it's a quadratic function. So I know the y-intercept is at 0 and then 1. Because it's positive 4, it's going to have a smiley shape with a minimum turning point. And that turning point is b over 2a, or x equals negative b over 2a. So it's going to be negative 2 over 2 times 4. So that's positive a quarter. So at a quarter here, it's going to have its minimum value. So the graph will look something like this. Okay. That is the function f. And then we know that there's some point, we don't know where it is just yet, right? We know it's AB, that when you take the tangent to that point, that the gradient, well, the equation is 14x minus 15. So the gradient of this tangent line is 14, and it cuts here at negative 15. So let's go ahead and do that. Well, the derivative of f from the power rule and the sum and difference rules, so it'll be 8x minus 2. Okay, and we want the x value that gives us a gradient of 14, because that's what the derivative is. It's the gradient of the tangent line. So I'll get 8x equals 16, therefore x equals 2, right? So I moved over the 2 to get 16 there, and then 8 times 2 is 16. So we know that the point of contact here, P, must be at 2, and to find the y value, I simply substitute it back into the original equation, f of 2. That's going to be 4 times 2 squared minus 2 times 2 plus 1. So 2 squared is 4, 4 fours are 16, minus 4 plus 1. So that's going to give me 12 plus 1 is 13. So there's the coordinate. P is 2, 13. And that's the tangent line. So great, we found the values of a and b. So we've done that. But now we want the equation of the normal line. So that's this line that goes like that. So it's perpendicular to the tangent line and also goes through that point of contact. So to get the gradient of the normal line, that's going to be negative 1 over the gradient of the original tangent line, which is 14. So therefore, the equation of the normal line is negative 1 over 14x plus c. Lastly, we'll substitute the point 2, 13 into that. So we'll get 13 equals negative 1 over 14 times 2 plus c. So that simplifies to negative 2 over 14 is negative 1 over 7 plus c equals 13. And therefore, c equals 13 plus 1 over 7. So if I simplify that, 13 over 1, 7 times 13, what is that? 7 times 10 is 70, 7 times 3 is 21, so together that's 91 plus 1, so 92 over 7. Okay, so therefore, the equation of my normal line is negative 1 over 14x plus 92 over 7. All right, and that makes sense. You can see that y value is positive, so that y-intercept makes sense. All right, so that was finding the coordinates given the equation of the tangent line and then also the equation of the normal line. Awesome. I'll see you in the next one.